I'm amazed by all you do. I'm amazed you came through for me. Even in my darkest moment, Baba, you lit up my world. I'm amazed by how you care. I'm amazed you're so full of love. You've been good from distant past, and yet you're still doing good. Obinigwe, Obinigwe, Obinigwe. All right. Thank you so much for the contribution. I welcome you all to OS e-learning platform. This is OPERO Stephen taking you through the tutorial of physics and mathematics. As the order of the day, before we commence on any discussion, let's first thank God for the gift of life. For we are not the special ones. Nothing we paid him for the gift of life. Father, we thank you. We bless your name. Thank you for loving us. As OS team, we can't continue unless you are with us. Father, lead us through this subsequent discussion. Be with us. All this we pray through Christ Jesus, the Son who lives and reigns within the unity of the Holy Spirit, one God forever and ever. Amen. Our brothers and sisters in different religious beliefs, the Muslims, we welcome you too. And all what we have prayed, we believe that through Christ's, Allah's name, we receive. Thank you so much. Let's embark on the discussion. Significant figures. Significant figures. We got to realize that at some points, as learners, we find it so difficult to differentiate what a significant figure is from a decimal place value. And then, at some point within the significant figures, we fail to consider when we count a digit as a significant figure, like those special cases we follow while counting a digit as a significant figure. So throughout this presentation, we shall actually go through all of them and get to realize how we count, or when do we count a value, a digit, as a significant figure. So what is a significant figure? Or what are significant digits? These are digits in a measurement that are known to be reliable and certain. They are used to express the precisions of measurements or calculated values. So that is basically a significant figure. And where do we apply this? We apply different arenas of life as far as measurement, recording, and calculations are concerned. The number of significant figures in a value indicates the degree of uncertainty in that value. The number of significant figures in a value indicates the degree of uncertainty in the value. Cases for when we count a digit as a significant figure. Case 1. Case 1. All non-zero digits are significant figures. That is 1, 2, 3, 4, 5, 6, 7, and 8 and 9. So all those digits, once you see them written somewhere, they are all significant figures. Whether they are in a decimal number or not, they are all significant figures. For example, if you have 4, 5, 6, those are basically three significant figures. That is 4, 5, and 6. 1, 2, 3, still those are three significant figures, as you can see them. 9, 8, 7, three significant figures. 5, 7, 5, 3, three significant figures. Case 2, the trapped zeros. Trapped means captured. So this is when the zeros are between non-zeros. So the zeros are between non-zero digits. And we agreed the non-zero digits are 1 up to 9. Then once a zero is in between them, whether these numbers are with decimals or not, what will happen is we shall actually count that zero as a significant figure. Check here. Example 1, we have 1, 0, 1. 0 is trapped in between 1, 1, and therefore this, since the rule calls for 0 to be counted as a significant figure, we shall have 1, 0, 1 as three significant figures in this digit or number. And that's 1, 0, and 1. Example 2, as you can see, 0 is trapped, so it's a significant figure, and therefore we shall have 3, 0, 1, 0, 4 as all counted as significant figures. 5, 0, 5 it still has all those three significant figures. Let's look at this case where you have a decimal point number, a decimal number, a number with a decimal point. Here, as you can see, the first two zeros after 8, we have trapped between the non-zero 8 and 1, and also after point we have 0, then 8, still the 0 is trapped. So basically here we shall count every digit and they will count as significant value. And that is having 6 significant figures. That is 8, 0, 0. Sorry, these are 3 zeros. 2 zeros, yes. 2 zeros. Yes, this 0 is not there. So basically we shall have 8, 0, 0, 1, 0, then 8. All these are 6 significant figures. Then the next example, we shall have 12.005. And since the zeros are trapped, we shall still count them as significant figures, and this will make a 5 significant figures digit. And that's 1, 0, 1, 2, 0, 0, and 5. So that is case 2, 3. When the 0 is at the end of a number with a decimal point, and the 0 is at the end, what we call the trailing 0 in the decimal point number. Ideally, that is a significant figure. As you can see, if you have 12.0, 12.0 is actually a significant figure, and then the digits 1, 2, and 3 will count significancy. And then 45.60, still we agree the rule says a 0 acting as a trailing 0 is to be counted as a significant figure. So all these digits are significant figures. 90.00000 has 7 significant figures, as we can see. The 5 zeros after decimal point and the 9 and 0. They are all significant figures. Actually, we are discovering that if you want to increase the number of decimal place after the number of values after a decimal place, for example, you want to increase the number of DPs, we just include a 0 to increase. And at some point, you shall realize that when I want to round off a certain digit to more decimal places, whereby we just need to increase the zeros, and that 0 will count a significant place value, a significant digit. So as we can see, all these examples all are counting significant figures. So we have the leading zeros in a number without or with a decimal point. How? Leading 0 in a number with or without a decimal point are not significant figures. Actually, they just indicate the position of a decimal point if it is a decimal point digit. And then if it is a number without a decimal point, still that leading 0 or the starting 0 is not counted as a significant figure. Examples, check the first three zeros, actually 0.006. All the zeros are not significant figure, then the 6 is a significant figure. So for this case, we shall have 6, which is a significant figure, and that is one significant figure. So if you are told to identify the significant figures in the second case, as you can see, there are two significant figures. Two significant figures still. All the leading zeros are not significant figures. Case when we have a non-decimal digit or number. We have 00056. Still 56 are the ones going to be counted. The ones counted as significant figures. Then this will act. We'll have two significant figures. Two significant figures. The other fifth case is when the 0 is at the end of a whole number with a decimal point. When the 0 is at the end of a number with a decimal point, without a decimal point, this 0 is not counted as a significant figure. And this is where students face challenges. A trailing 0 in a non-decimal point number, for example, 200, 300, 750, the last zeros are not counted as significant figures. Examples, as you can see, 400 has only one significant figure. All the zeros are not counted as significant figures. One significant figure. The next example, one significant figure, 1. Oh, it's unfortunate that all my examples are having 1. Even if you said 7250, you shall have 3 significant figures. Let's just try it here. If I have 7, 2, maybe 4, 0. So this 0 here is not counted. Here we shall have only 3 significant figures, which will be 7, 2, and 4. Another example, someone can say, teacher, how about 2, 4, maybe 5, 6, and then 0, 0. So we agreed these zeros here are not going to be counted. Then we shall just count the 4 significant figures. Then once you mix that with the trapped 0, then you just know the rule calls for that 0. For example, 705 or 7,050. If you look at this 0 is not counted because it is a trailing 0 in a non-decimal number, and then this 0 is counted because it is a trapped 0, however much it is in a non-decimal number. Decimal places. How do we count the decimal place of a number? And then soon we shall round off as well, truncate, then respecting the decimal place and also the significant figures. Definition of decimal place. A decimal place or decimal places. Decimal places refer to the number of digits to the right of a decimal point in a number. Like the number of digits you have after a decimal place to the right. Those numbers, we just count them. They do not respect whether it is a 0 or a non-zero. They are all counted as decimal places because they are holding places. So the decimal places are used to express the precision of a measurement or a calculated value. Examples are here just to identify how many decimal places. Okay, which this digit is written to how many decimal places, and this is basically we count numbers to the right. We count number to the right after decimal place. So after decimal place to the right, we are moving this side. So to the right, how many numbers do we have? I see 3 and 4. So those are two digits. Therefore, they are holding 2 places. And therefore, that will be 2 decimal places. 2 decimal places. 2 decimal places, please. Next. We are still counting. As we can see, 1, 2, 3, 4, 5, 6, 7, 8. Those are 8 decimal places. So this number is written to 8 decimal places. 3, 4. After 0 to the right, we have 6. So the difference between rounding off and truncating numbers. So rounding off and truncating numbers are two essential techniques used to approximate values to a desired degree of precision. Understanding the differences between these methods and how to apply them correctly is crucial in various mathematical and scientific applications. We do very many scientific experiments or investigations, and by the end of the day, we record our observations in tables. At some point, we are required to respect the rule of significant values or figures and also rounding off. So we need to master this concept in this tutorial, and then we'll be in position to correctly apply them because they are so crucial. Rounding off a number to a specified number of significant figures or decimal places. When rounding off, you examine the digit to be rounded and the digit immediately to it is right. Immediately to it is right. For example, if the letter digit is less than 5, you round down. This is what they are meaning. Let's use our example. As you can see, we have 3.14153. If we want to round this digit, to 4 decimal places, it is already in 5 decimal places. So we want to round it to 4 decimal places. And we agree that to count the number of decimal places, after a point we move to the right. So now to the right we have 1, 4, we have again 1 and 5. But the rule is that we check on that number immediately to the right. And here we want to round off to 4. So this is the fourth one, the fourth digit. Now to immediately to it is right, we have 3. And we agree that 3 now is actually less than 5. So for that case, we just round down. What does it mean by rounding down? We shall not increase any digit to this 5 to make it maybe 6 because 3 is less than 5. So for that case, we shall have the original value as 3.1415, which is to 4 decimal places. Or if you want to round this to 2 decimal places, still to 2 decimal places, to 2 decimal places. If you check on the decimal places, here we have there 5. Then the 5 decimal places, we just need to pick only 2 digits after a decimal place. These 2 digits are the ones we want. They are the ones making 2 decimal places. So we check on the last digit or the first digit just after the 4, which is making the second decimal point. So if you look at this one is actually less than 5. Then for that case we shall still round down. So we shall have 314, which is 2 decimal places. How about if you wanted 3 point, to 1 decimal place? Still this one is the one making the 1 decimal place. Then we check on the digit immediately to it is right, which is a 4, and the 4 is still less than 5, so we shall keep 3.1 to 1 decimal place. How about to 0 decimal place? 0 decimal place, still we shall see that we need to remove all the decimal places here, the decimal place values. So we shall remain with a 3, because after a 3 we have a decimal point, but the decimal point, after decimal point we have 1. So this one is less than 5, therefore we shall not increase anything to 3. So therefore we shall just remain with our 3, and for that case we shall just have 3. Don't write 0.0. If you create 0.0, you have actually increased the number of decimal places, and then you have also increased the significant figure, because here it will become two significant figure, because a 0 after a point, any 0 after a decimal point is counted as a significant figure. So don't write 3 points, so just write 3, and that 3 will act as a significant figure in case you write it, and it will also act as a decimal place. Yes, we are right, yet we are writing it to 0 decimal place. Another case, now when it is greater than 5, what do? We have to round it up. As you can see, 3.76566, if I want to round it to 4 decimal places, so let me just explain that one shortly. You can see that the first 4 digits that I want to consider are this one, so it is I'm ending on 6, but after 6 I have a 6 which is actually greater than 5, so I will round up. I will just borrow 1 and add it on this 6, and that will be 3.7. Sorry, where is the answer? Yes, it is here. 3.7657, because this 6 will become a 7 after adding a 1. And then if I want to make it to 3 decimal places, still the first values I want are these ones here. But now after 5 I have a 6 which is a 6 greater than 5, so I have to shift and I add a 1 on this 5, and that will make 6. So that will be 3.766. These are 3 decimal places, and also making 4 significant figures, as we shall discover in the subsequent examples. 3.77 is to 2 decimal places, because we agree this, if I want to take the first 2 to make 2 decimal places, but there is a 5 which is actually equal to 5. So for that case we shall still do what? Round up. Then to 1 decimal place, this is 7 here is the one we want, but 6 is close to it, so we shall increase this 7 by 1, since the rule is that the value immediately after 7 is 6, which is greater than 5, and therefore we shall do what? We shall round up. So we shall borrow 1 from that 6 to make 7 become 8. So for that case, we shall have 3.8, 1 decimal place. Then to 0 decimal place, we shall just have 4. We agreed to don't put a point. Why are we putting a 4? Is that we want to remove all this, but after a point I have a 7. A 7 which is actually greater than 5. So I have to borrow 1 and add it on 3 to make 4, and I don't put any point. So that will be 0 decimal place. I don't have a point here, so that's why it's called a 0 decimal point. So let's check on these examples. We are rounding to 4 decimal places, and then we are saying since the digit after the 4th, because we want to write it to 4 decimal places, is 9, which is greater than 5, then we round up and we increase that. Then if you look at the second example, we want to round to 2 decimal places. So our target is here, but since 8 is greater than 5, so I will shift a 1 and it becomes 2 here. So that's why it will be 2.72. So when you're rounding off to decimal places, the digits that we count after a decimal point are the ones that should respect to the demand of the task. So that's why if they tell you to round to 2 decimal places, it means that after a decimal point you must have only 2 digits. Now these 2 digits the last digit can either increase or remain the same. So if it increases, it becomes rounded up. If it is reduced, if it remains the same, it is rounded down. And rounding up means we are borrowing a 1 from the value just after that last digit that respects the decimal place required. So we'll borrow that 1 and we round up. If the last digit or the next digit after the digit that respects the demand of the decimal place, if it is greater than 5, then we borrow 1. If it's less than, we round down. Then how about rounding to given significant figures? For this case, We have 0.056789. We want to round to 3 significant figures. Now, if you look at this 0 is actually not counted. If you remember the rule very well, this 0 is not counted. Even this 0 is not counted. So in this digit, we have 1, 2, 3, 4, 5 significant figures. So we want to reduce these significant figures to 3 significant figures, meaning our target is to end here. But now the rule is for rounding is that if this value immediately to the right is actually greater than 5, we shall borrow 1, and this will make 7 become 8. And therefore we shall have 0.0568, because still 0 is not counted as a significant figure. Even this 0 is not counted. So these are the 3 significant figures we shall count. And this last value here is becoming 8 instead of a 7 because we have rounded up. Another question is here to 1 decimal place. So these are 2 digits making 2 decimal places. We want to round it. Of course, we shall round up, and this will become 0.6. So the response will be 1235.34, which is to 1 decimal place. Now the question is, if we were tasked to round it to how many significant figures. Let's first check how many significant figures do we have here. These are how many? All are non-zeros, and they are counted as significant figures. So we shall have, there are 6 significant figures. Then if our target is to round to 5 significant figure, it is like rounding it to 1 decimal place. So this will be, our target is to end here. But if you check on 6, 6 is greater than 5, so we shall borrow 1 to make this one a 6. Actually, what we've done in this example is that we have done 2 things in one. One, we've rounded the digit to 1 decimal place. At the same time, we have actually rounded the digit to 5 significant figures. Look at this. Round to 2 decimal places. The digit itself has 3 decimal places. So if I want to round this to 2 decimal places, my target is to end here on 5. But if you check on 4, our 4 is actually less than 5. So we shall not round up. Instead, we shall round down. So basically, those are a few examples. I will task you also to create your examples as you play with these digits. And guess what? By the end of the day, we shall be on the same page. Please, if you have any question, paste that question on the comment section. Drop that question down. Any query, any confusion, any clarification you need, kindly ask. Don't forget to like, subscribe. Please share the video. Let's spread the mathematics, spread the physics. Let's spread this knowledge to different parts of the scientific notations. My senior 1 friends, you remember this, that in our first term in senior 1, we need to leave the class after understanding what scientific notation is and how to play with it. Basically, this is a way of expressing very large or very small numbers in a compact form, in a simpler form. It is especially useful in science and engineering to make numbers easier to work with. So scientific notation expresses a number as a product of 2 parts. That is when we have a times 10 power n, where a is a digit and n is also a digit, which can be a negative digit or a positive digit. A is a number that is actually greater than or equal to 1 and less than 10. Yeah. However, when it comes to indices, even if it is 10, we shall respect the power, the rule of indices. But basically, I'm still talking to all students, right from senior 1 to senior 6. So if I'm talking about this a as a number less than 10, you should understand me in that context. And if I'm talking about this a being greater than 0, you should understand, because when you multiply a number with any digit, of course the 0 nullifies everything to 0. So the coefficient a is actually a digit which is not a 0 and also not actually equal to 10 in this context. N is an integer which is a positive or a negative. Of course, you know that. And then if you have a times 10 power n is 10 raised to a power n, called an exponent. So a exponent n, where n is a positive or a negative. So for larger numbers, how do we write them in a scientific notation? Examples. If you are requested to convert 72,000 to scientific notation, step 1, we place the decimal after the first non-zero digit. And the first non-zero digit here is what? 7. So this is the first. The first non-zero digit here is 7. So the decimal point will be placed here. So that is the first step. Step 2, count the numbers, the number of places you moved to. Count the number of places you moved to the decimal to get back to the original number. So for me to get to that decimal, I have to move how many places? 1. Oh my god, my pen. What are you talking about? What? Check here. So we are going to move. This is 1, 2, be patient, 3, 4. So that is the power I'm going to raise. So after raising that, I moved, now it's not you, please. Moved 4 places to the right. Okay. I moved to the left. Oh, what am I also thinking about? So we are going to move to the right. The logic is very simple. We move to the right. This is the decimal place, so I will move 1, 2, 3, 4. So those are 4 places to the right, please. So it is going to be a positive. Why do we respect the right and the left? If it is to the right, then that is a positive power. So we shall have 7.2 to 70,000. Step next, write it in the form AX. So basically that A will be 7.2, then N will be positive 4. Example 2, as you can see. Example 3, the first digit, non-zero, is 6. I put a point there, so I move to the right to restore the original value. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9 on the the third example. Next, okay. So the task is we need to express 945. These are 3 significant figures, and I want to write it in a scientific form. So what I will do is, as usual, I will move a decimal point just after the first non-zero digit. Then I move to the right to restore the original value, and that will be 2 places, and therefore we'll have 9.45 times 10 power 2. Why is it a 2? I've moved the 2 places and to the right, to the positive. Another example is there. Now this one is with a decimal. So place a decimal after the first non-zero digit. I'm placing it here. Step 2, count the number of places you move to decimal to get back to the original number. So if I want to get back, I will have 1, 2, 3, 4. So here I'm moving a negative, meaning the power is going to be a negative. If I'm to restore the number back to its original position, original question, so I will have moved 1, 2, 3, 4. So still it's going to be 4. And for that case, those are the negative 4 places I've moved. Why is it negative? Because it's to the negative. And then that will act as I'm writing it in that form, exponential form, that will be 5.4 exponent negative 4. The next example here, I place here my point, then I count just after the first, because the first non-zero digit here is 3, so I need to count but to the left. So this is going to be 1, 2, 3, 4, still negative 4. The same story here, I put here point, then I move 1, 2, 3, 4, 5, 6, 7, 8. So still that is a negative, so that will become negative. So how about 2.45? How about that one? These are 3 significant figures, 2 decimal places. I want you to write this in just a simple scientific form. How are we going to get that? Can you paste the answer in the comment section? Can you please paste the answer in the comment section? So this case is for actually smaller numbers, those numbers that are less than 1. But now if you look at this case, this number is greater than 1. So what do? We go back to the previous chapter, then you check. So I will get your answer in the comment section. Once you reach on this part, please paste that answer to check our contribution. Something to note: 1, the rule of counting decimal places. So to determine the number of decimal places the number of decimal places in a value, we have to respect some perimeters. 1, count the digits to the right of the decimal point. That is obvious. Those are things that we need to know also. Zeros at the end of a number with a decimal point are significant. I repeat, with a decimal point. This one here, with a decimal point. But without a decimal point, they are not significant. Be aware of scientific notations and its rules. For example, when we need to round off or truncate something, be mindful about that. Common mistakes we make: we confuse place value with the place values. Sorry, we confuse decimal places with scientific figures. Don't confuse the two. Not counting zeros at the end of a number with a decimal point. And sometimes we count zeros at the end of a number without a decimal place or decimal point, counting them as significant figures. Those are mistakes we make. Don't, please. Not considering scientific notations when counting decimal places. Tips and tricks: when rounding numbers, consider the number of decimal places. When expressing numbers in scientific notation, consider the number of decimal places. Be aware of the precision of your measurements and calculations. Practicals, physics. Be aware of that. Truncating a number of a number to a specified number of significant figure or decimal places. Truncating means chopping or cutting off the digits after a specified point without rounding off. That is rounding down or rounding up. We don't respect that, we just chop. This means we simply remove the unwanted digits without considering whether to round up or down. Like an example, if I want to truncate this to 2 decimal places, I want only 1 and 4. So I don't want to mind whether 1 is, after 4, 1 is greater or less. I don't want to know that. 2 decimal places, I just want 6 and 5 at the end. 1 decimal place, whether 6 is greater than 5, I don't want to know. I will just chop that 6 and I remain with the 0.5. That is 1234.5. That is 1234.5. 2 decimal places, I just want 0.05, period. 1 decimal place, 2.7. 0.8. The 0 decimal place, yeah. So we don't put a 0. This is a full stop, please. This is a full stop. Don't call it a 0. Now, how about to significant figures? Let me just use this page to do that. For example, 3.14. This is 3 significant figure. If I want to truncate this to 2 significant figure, I will still just chop that 4. I will remove that 4 and my response will be 3.1. So these are 2 significant figures. So here we basically chop. We don't mind of rounding up or down. The key difference is 1. Rounding off takes into account the digit to be rounded and the one immediately after it. Truncating simply cuts off the digits after a specified point without considering rounding rules. That is, rounding off if the digit is to be rounded is followed. Next, if a digit is to be rounded, you follow the rule of greater than 5, that is round up, otherwise less than 5, round down. Truncating simply cut off the digits after a specified value without considering rounding. So those are tips that you should keep in your activities. Kindly try these activities. So that is one activity. Try it out and we confirm whether the response is correct. Another one is here. 1, 2, 3, 4, 5. Stop. Confirm the response. Well, you can be pausing the video before you see the response as you try your luck. So the responses are there. You confirm that. Well, after analyzing all this, let's get into the sample items.
So what day is the land?
Worthy is the Lamb that sits upon the throne. Thank you so much for watching. I bless you. May God keep you alive. May we meet again. Kindly take care of yourselves. Keep praying. Keep chasing your dreams. I love you.